All right, Math 10s, this is the first example, first video for lesson 2.4 about the sine and cosine ratios. Before we dive into those, I just wanted to quickly do a review of what a similar triangle is. So these two triangles here would be called similar triangles. Notice one is exactly twice as big as the other, not that I measured them, but in terms of the sides, which means the ratio of their sides would all be the same. So if we did some of the previous lessons work on tan, you'd find the same angles in all three positions on this triangle. The same is true if I triple the side lengths rather than double them. All three of these triangles would have the same angles within them. So that's what makes them similar triangles. Different sides, same angles. Okay, this diagram is something you've seen before. Just reminding you about the vocabulary of what's an opposite side, an adjacent side, and a hypotenuse. So if I'm labeling that angle there as theta, that small acute angle in the bottom left, the side that has nothing to do with it, essentially, that's on the opposite side of the triangle, is called exactly that, the opposite. The hypotenuse has to be across from or opposite the 90, and the other side, the side beside the angle, is called adjacent. We've spent the last couple of lessons talking about the tan ratio, tan being the ratio of the opposite side divided by the adjacent side. It turns out that there are two other ratios that we'll use in this chapter as well. One is called the sine ratio, and you can use it in very similar types of questions, except in the case where you're talking about the opposite side and the hypotenuse instead. And then the cosine ratio, which is the adjacent divided by the hypotenuse. Some people use a very strange memory device that sounds like another language, so katoa. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. The truth is, you get these on your Math 10 formula sheet anyway, so you don't really need to memorize them. So a quick example of a use for these. If we take the triangle we looked at a minute ago with sides measuring 4, 3, and 5, and let's say we're talking about that bottom left angle again, the question, if the question asked us what's the measure of that angle, in previous lessons we would have automatically used tan. We'd said, well, tan ratio would be 3 over 4, so inverse tan of 3 over 4 will give me the angle. Well, in some questions you won't have the opposite and or the adjacent. You might have the opposite and the hypotenuse, in which case in this triangle you could have said sine of theta would be 3 over 5. And notice you do get the same answer. Inverse sine of 3 over 5 gives you right down to all the decimals, 36.89 whatever degrees, 36.9 or 37 degrees. Similarly, if you had the adjacent and the hypotenuse, so if somebody did not give you that length of 3, you could set up a cosine ratio and say, okay, well, cos would be 4 divided by 5, the adjacent of the hypotenuse, and if cos is 4 over 5, inverse cos of 4 over 5 gives me an angle of 36.9 degrees. So not super useful in a question where you have all three sides because it's kind of unnecessary, but as you'll see, there'll be lots of questions where they might not give you this 3, in which case you would have to use the cosine ratio, or maybe they don't give you this 4 and they give you the 3 and you'd use the tan rate or the sine ratio. So we'll do some examples in the next video where you have to use one or the other.